Public perception and behavioral engineering operate on a shared, deeply entrenched premise. Dopamine is the brain's primary chemical of pleasure. This model dictates a straightforward biological equation. The pursuit of a reward is identical to, and driven by, anticipating the pleasure that reward will deliver. Pharmacological studies on humans reveal a severe discrepancy in this equation. When researchers suppress dopamine neurotransmission in test subjects, their subjective pleasure ratings for drug or food rewards do not drop. Clinical observations of Parkinson's disease provide further evidence. Parkinson's is characterized by severe dopamine depletion, yet patients demonstrably experience intact hedonic pleasure, identifiable enjoyment, from tasting delicious foods. Modern neuroimaging clarifies exactly what dopamine tracks. Scans show that dopamine levels correlate highly with how much a user wants a reward, but have almost no correlation with how much they like it upon consumption. Dopamine does not mediate hedonic pleasure. It strictly mediates the biological drive to pursue, a process known clinically as incentive salience. Operating under the dopamine pleasure fallacy prevents us from understanding the true mechanics of addiction. We cannot explain why people compulsively pursue behaviors or substances they actively despise until we separate the desire from the enjoyment. The empirical separation of motivation and pleasure begins with a 1989 experiment by researchers Kent Berridge and Terry Robinson. Initially, the study was designed simply to confirm the standard dopamine pleasure hypothesis in rats. They used a precise experimental mechanism, a 6-hydroxydopamine neurochemical lesion, to deplete nearly all brain dopamine in the test subjects. Under the established scientific model of the time, the expected outcome was definitive. Without dopamine, the test rats should completely lose the capacity to feel pleasure when given a sweet sucrose reward. The results contradicted the hypothesis entirely. The lesion rats exhibited entirely normal affective facial expressions of liking when tasting the sweet sucrose. Researchers measured specific biometric markers. They recorded relaxed facial expressions and rhythmic tongue and mouth movements, physical indicators of pleasure that are homologous across humans, apes, and rats. The pleasure response was completely intact, but the behavioral drive was gone. The lesioned rats lost all motivation to pursue or consume the sucrose on their own. They enjoyed the food, but they no longer wanted it. This forced researchers to locate the true anatomical source of pleasure in the brain. They identified a series of localized centers called hedonic hotspots. These hotspots are anatomically fragile. In the rat nucleus accumbens, the hotspot measures exactly 1 cubic millimeter, making the physical circuitry for pleasure highly restricted and easily disrupted. These hedonic hotspots, specifically a crucial node located in the ventral pallidum, are stimulated by opioid and endocannabinoid neurotransmitters. Dopamine plays no role in their activation. The brain physically isolates the circuitry for enjoying a reward from the circuitry that drives the biological pursuit of it. This map illustrates the physical disparity. The liking network is isolated to tiny restricted hotspots. Overwhelming them is the massive dopamine projection extending into the striatum. Notice these lines pulsing rapidly when a visual cue enters, tagging it with intense motivational urgency. When this system is repeatedly exposed to high-yield stimuli, it undergoes long-lasting structural changes. This is the foundation of the incentive sensitization theory. We must differentiate tolerance from sensitization. Tolerance is a temporary cellular suppression. Neurons attempt to turn down overstimulation, which reduces the actual liking impact of a stimulus. Sensitization operates in the exact opposite direction. It structurally alters the neurons to make the brain hyper-reactive to the cues associated with the reward, escalating the wanting response. These are physical, morphological changes. Sensitization alters the specific shape and increases the number of dendritic spines on neurons in the nucleus accumbens, effectively expanding the receiving antennae for incoming urges. Because this involves physical restructuring, sensitized wanting can persist for years after the stimulus is removed. Vulnerability often grows stronger during periods of abstinence, a measurable biological phenomenon known as the incubation of craving. These urges are state-dependent. High-stress environments, emotional excitement, or intoxication drastically amplify the dopamine system's reactivity to environmental cues. A sensitized pulse of dopamine and motivation only lasts for a few seconds or minutes. However, it generates enough biological urgency to easily override a person's declarative cognitive goals. Severe addiction is a compulsive, structurally enforced response to environmental cues, driven by a hypersensitized dopamine system. It occurs entirely independent of pleasure. This neurological architecture maps directly onto modern behavioral compulsions. Clinical frameworks like the I-PACE model for internet use disorders track how interaction, affect, cognition, and execution break down under digital stimuli. As seen in this point of view sequence, AI-driven social media feeds function perfectly as high-frequency, infinitely optimized environmental cue generators. Advanced machine learning models utilize clustering and linear regression to analyze user behavior. They interpret sentiments and interests to tailor these feeds directly to an individual's specific psychological vulnerabilities. The neurological sequence of a to-evil interaction follows a strict pathway. A personalized content tile acts as the environmental cue, instantly triggering the sensitized ventral striatum. This cue triggers a massive dopamine pulse. It drives the incentive salience to click or scroll, a reflex operating completely independent of whether the user will actually find the resulting content pleasurable. The algorithm's operational parameters clash with the user's conscious experience. Algorithms do not optimize for satisfaction. They do not optimize for liking. They strictly optimize for cue-triggered wanting to maximize time on device. The infinite scroll is an engineered exploitation of the brain's fundamental dissociation between biological motivation and actual pleasure. Chronic exposure to these artificial cue-triggered dopamine surges causes measurable structural volume loss in the brain. As the striatum pulses rapidly, generating the urge, the physically weakened prefrontal cortex, responsible for executive decision-making, fails to intercept the command. Damage also accumulates in the amygdala. This leads to increased emotional sensitivity, poor impulse regulation, and a heightened biological vulnerability to depression. Secondary physiological impacts compound the issue. Late-night screen behavior suppresses melatonin secretion, desynchronizing the hypothalamus's circadian rhythm and severely degrading sleep architecture. Traditional behavioral treatments relying strictly on cognitive willpower consistently fail. They demand that a physically weakened prefrontal cortex combat a hypersensitized mesolimbic system. Effective neurobiological treatments must target the underlying neuroadaptations, such as altering glutamate signaling pathways. Simply blocking dopamine is not viable. Doing so destroys all normal human motivation. Ethical platforms must be audited by different metrics. Measuring aggregate screen time is insufficient. The audit must target a platform's structural exploitation of the incentive salience pathway. Reclaiming human focus requires abandoning the idea that behavioral addiction is a moral failing. It is a systemic, engineered hijack of our neurobiology. Modern life forces us into a frantic dash for cash. We pack in work, obligations, and endless digital distractions. This creates a powerful centrifugal force that pulls our focus outward, draining our energy and forcing our biology into a slumped, passive state. This diagram maps biological failure. Dr. Sven Hansen calls this the death spiral, a progressive collapse of mind, emotion, and body. But the top maps the opposite state, gaining altitude. You can train your body, engage emotions, and master stress. Resilience is a physical action. To climb out of the bottom rings, you have to stop passively watching the screen and physically participate right now to alter your biology. To map your biological system, think of a carriage. The cart is your physical body. If the cart is broken, the journey stops immediately. We fix the cart first. Step 1 of this reset starts right now. Sit perfectly upright in your chair. Relax the muscles in your face. Now exhale slowly through your nose. By lengthening your spine, you send an immediate signal to your brain. This specific posture correction actively increases your testosterone and drops the stress-inducing hormone cortisol. Step 2. Stretch both of your arms behind your back to completely open your chest and shoulders. Step 3. Stand up. Take 15 seconds to walk briskly around the room or climb a flight of stairs. Force your kinetic movement. Mastering these physical inputs is your first line of defense against the death spiral. Your physical capacity dictates your ability to control your mind and your emotions. Now we address phase 2, the horses pulling the cart. These represent the unpredictable power of human emotions. Step 4. Identify 3 specific, realistic things in your life that you are genuinely lucky to have right now. We are not practicing fake positivity or unearned self-esteem here. Psychologists call that boosterism, and lying to yourself will fail to alter your biological baseline. Honest, grounded gratitude acts as a literal counterweight to fear and anxiety. It anchors your nervous system back into reality. Stabilizing these emotional horses prevents panic, preserving the vital biological energy you need for higher-level cognitive problem-solving. That brings us to phase 3, waking the driver. The driver is your mind, and right now we need to force outward cognitive connection. Step 5, pick up your phone and immediately send a short, appreciative text message to someone close to you. Step 6, close your eyes for just a moment and send a silent pulse of kindness or compassion towards someone you love. Finally, we reach the passenger resting inside the cart. This represents your spirit, or your sense of larger, mindful purpose. Step 7, look away from all screens. Spend 10 seconds absorbing the physical beauty of a natural object or art in your immediate environment. By sequentially aligning your body, your emotions, your mind, and your spirit, you have engineered a state of holistic biological engagement. Take a moment to evaluate your physical and mental state right now. Notice the measurable increase in your clarity and physical energy compared to the beginning of this video. Looking back at the diagnostic spiral, we can visually confirm your new biological position. You have climbed up into the top tier, spirit in action. Here is the complete 7-step resilience reset protocol. Take a screenshot of this list right now and memorize it. Resilience is a highly deployable biological tool. You can use this sequence to conquer the daily dash for cash whenever adversity strikes.